Welcome to online engineering drawing class. The previous class continuation. We can learn introduction. Geometrical constructions are completed. Now we are going to learn scales. In engineering drawing, what are the scales we will use? In a plane scale, diagonal scale, vernier scale, comparative scale or corresponding scale, scale of chords, etc. we will going to learn in detail.
Learning objectives. After the completion of this chapter, you will be able to know about the scales that are used in practice. The plane scale, the diagonal scale, the vernier scale for length measurement, the comparative scale or corresponding scale, scale of chords for angle measurement.
The scales introduction.
Introduction. Engineering drawing is a representation of an object, the details of which have to be studied and understood by different persons for interpretation. It is not always possible to prepare drawing to the exact dimension of the object. This is because we may have to represent objects of both bigger size, like a building structure, engine, etc., and also smaller size, like parts of a wristwatch, electronic gadgets, etc. The intention, of course, is that the prepared drawing should be such that it can be read and handled conveniently. In the modern drafting system, scale sets in which length units are set to various scaling are available. However, if such scale sets are not readily available, then the construction of scales becomes necessary. A scale is defined as a ratio of linear dimensions of an element of the object as represented in a drawing to the actual dimension of the same element of the object itself, in comparison with the corresponding dimensions of the object we use. Enlarging scale if the drawing dimensions are proportionately enlarged. Reducing scale if the drawing dimensions are proportionately reduced. Full size scale if the drawing dimensions are same.
Once again, after completion of the scale, we are going to learn
learning objectives. After completion of this chapter, you will be able to know about the scales that are used in practice. The plane scale, the diagonal scale, the vernier scale for length measurement, the comparative scale or corresponding scale, scale of chords for angle measurement. Introduction. Engineering drawing is a representation of an object, the details of which have to be studied and understood by different persons for interpretation. It is not always possible to prepare drawing to the exact dimension of the object. This is because we may have to represent objects of both bigger size, like a building structure, engine, etc., and also smaller size, like parts of a wristwatch, electronic gadgets, etc. The intention, of course, is that the prepared drawing should be such that it can be read and handled conveniently. In the modern drafting system, scale sets in which length units are set to various scaling are available. However, if such scale sets are not readily available, then the construction of scales becomes necessary. A scale is defined as a ratio of linear dimensions of an element of the object as represented in a drawing to the actual dimension of the same element of the object itself, in comparison with the corresponding dimensions of the object we use. Enlarging scale if the drawing dimensions are proportionately enlarged. Reducing scale if the drawing dimensions are proportionately reduced. Full size scale if the drawing dimensions are same. Representative fraction. It is the ratio of the drawing size of an object to its actual size, abbreviated by RF. Representative fraction RF is equal to dimension of an object in drawing divided by actual dimension of the object. Here, both numerator and denominator should represent the same length unit. As per BIS convention, the numerator is always 1 centimeter and the denominator is represented accordingly.
Now the problem number 1. A line of length 5 m on the object is represented by a line of 5 centimeters length on drawing. Calculate representative factor of the scale is like this. For given problem, solution is here actual length is 5 meters, that is 5 into 100, that is 500 centimeters. Drawing's length is 5 centimeters. So therefore the ratio factor will be calculated drawing length in centimeters by actual length centimeters, that is 5 by 500, that is 1 by 100. Hence RF is used is 1 by 100, or more conveniently 1:100. Now next, scale RF point to merge. This table I will write. Reducing scale 1:100, the numerator is always less than denominator. Full scale is almost RF is 1:1. The numerator is equal to denominator. Enlarging scale 10:1, which is the numerator is always greater than denominator. Now types of scales.
Types of scales. The scales used in practice are classified as given below: plane scale, diagonal scale, vernier scale for length measurement, comparative scale or corresponding scale, scale of chords for angle measurement. Plane scale. A plane scale represents 2 units or a unit and its subdivision. Plane scale consists of the drawing length divided into number of equal parts. The first such unit on the left is further divided into equal smaller parts. Construction of plane scale. Choose the RF or calculate if it is not given. Find the scale length L using the formula L is equal to RF into maximum actual length, round off L to the next higher whole number. Draw a line of length L and divide it into required number of equal parts. Each part represents the main unit. Put 0 at the end of the first unit and number towards right. Subdivide the first main unit as required and number the subdivisions proceeding to the left of 0. Print the name of main and subunit just below the left side and right side of the scale. Mention the RF of the scale beneath the drawing. Indicate the length asked for, if any, on the constructed scale. Problem number plane scale to read centimeter and decimeter. The scale should be long enough to measure 6 decimeter. Take RF as 1 by 4. Show a distance of 4.9 decimeter. Solution. Given RF is equal to 1 by 4, that is equal to drawing size by actual size. Maximum length to measure is equal to 6 decimeter, that is equal to 6 into 10, that is equal to 60 centimeters. Therefore, scale length L is equal to RF into maximum actual length. That is, L is equal to 1 by 4 into 60, that is equal to 15 centimeters. Problem number 2. Construct a plane scale to read centimeter and decimeter. The scale should be long enough to measure 6 decimeter. Take RF as 1 by 4. Show a distance of 4.9 decimeter. Solution. Given RF is equal to 1 by 4, that is equal to drawing size by actual size. Maximum length to measure is equal to 6 decimeter, that is equal to 6 into 10, that is equal to 60 centimeters. Therefore, scale length L is equal to RF into maximum actual length. That is, L is equal to 1 by 4 into 60, that is equal to 15 centimeters. Draw a line AB representing length of scale 15 centimeter. This length represents 6 decimeter and so divide it into 6 equal parts. Put 0 at the end of the first main part and number towards right as 1, 2 up to 5. Subdivide the first main part into 10 equal divisions, each subdivision representing 1 centimeter. Number 1, 2, 3 up to 10 moving towards the left of 0. Print decimeter at the right end and centimeter at the left end, and the R is just above the scale. It is required to mark a distance of 4.9 decimeters on the scale. Mark a point D on the 4th main division line. Draw a line from D up to 9th subdivision and call this end as C. Line CD represents 4.9 decimeters. Note: the height of scale can be any appropriate value. Draw a line AB representing length of scale 15 centimeter. This length represents 6 decimeter and so divide it into 6 equal parts. Put 0 at the end of the first main part and number towards right as 1, 2 up to 5. Subdivide the first main part into 10 equal divisions, each subdivision representing 1 centimeter. Number 1, 2, 3 up to 10 moving towards the left of 0. Print decimeter at the right end and centimeter at the left end, and the R is just above the scale. It is required to mark a distance of 4.9 decimeters on the scale. Mark a point D on the 4th main division line. Draw a line from D up to 9th subdivision and call this end as C. Line CD represents 4.9 decimeters. Note: the height of scale can be any appropriate value.
Similarly, the problem number 3, a rectangle plot 16 square kilometers in area is represented on a map by similar rectangle of area 1 square centimeter. Draw the plane scale to show units of 10 kilometer and single kilometer and long enough to reach 60 kilometers. Find the RF. Also show a distance of 53 kilometers on it. Solution. The area of 1 centimeter square on drawing represents actual area of 16 square kilometer. That is 1 centimeter square is equal to 16 kilometer square. Taking square root on both sides, root 1 into root centimeter square is equal to root 16 into root kilometer square. So therefore 1 centimeter square is equal to 4 kilometers is equal to 4 into 1000 meters into 100 centimeters. Now 1 centimeter is equal to 40 lakh centimeters. Scales thus RF is equal to 1 by 4 5 zeros. Maximum action length 60 kilometers. That is equal to 60 into 1000 into 100. That is 6 00030 centimeters. Therefore, scale length is equal to 1 by the RF into maximum actual length, that is equal to 60 by 4, which is equal to 15 centimeters. Draw a line AB of 15 centimeters representing 60 kilometers. Divide it into 6 equal parts, each main part representing kilometer in 10 seconds. 10s. Subdivide the first main unit into 10 equal parts. Each subdivision shall indicate 1 kilometer. To represent 53 kilometers, draw line CD from 5th main division to 3rd subdivision. Now, problem number 4. A bus is flying at a speed of 45 kilometers per hour. Construct a plane scale to reach up to 1 kilometer and 1 unit. The maximum distance measurable is to be 40 kilometers. Take RF of 1:25, 2,50,000. On the scale, show the distance covered in 36 minutes. Solution. Length of kilometer scale given RF is 1 by 2,50,000. Maximum length is equal to 40 kilometers. That is 40 into 1000 into 100 centimeters. Scale length is L is equal to 1 by 2,50,000 into 4 lakhs. 40 lakhs. That is L is equal to 16 centimeters. A length of minute scale. Speed of bus is equal to 45 kilometers per hour. That is 45 by 60 is equal to 3 by 4 kilometers per minute, which is equal to 0.75 kilometer per minute. As per RF, 1 centimeter represent 2,50,000 centimeters or 2.5 kilometers. Distance covered in 1 minute is equal to 0.75 kilometers. That is 0.75 by 2.5 is equal to 0.3 centimeters. Therefore, 1 minute represented by 0.3 centimeters, or 1 centimeter represent 1 by 0.3 minutes, and drawing length 16 centimeters represent 16 by 0.3, which is equal to 53.33 minutes. Thus, 16 centimeters is equal to 40 kilometers, and 16 centimeters is equal to 53.33 minutes. Scales. Since the minute scale becomes fractional, let us choose scale length L as 16.8 centimeters, which will represent 42 kilometers and 56 minutes. Now, draw a line AB of length 16.8 centimeters, divide it into 7 equal parts, each part representing 42 by 7 is equal to 6 kilometers and 56 by 7 is equal to 8 minutes. Divide the first unit of kilometer scale into 6 parts and minute scale into 8 equal parts. To indicate the distance covered in 36 minutes, that is 32 plus 4 minutes. Mark a line CD starting from 4th main division of minute scale and up to 4th subdivision. This line CD represents 27 kilometers, which is the distance covered in 36 minutes. Now next topic, diagonal scale.
Diagonal scale. Diagonal scale is used to measure 3 units or a unit up to 2 decimal digits. For example, We can measure a length in meter, decimeter and centimeter, or meter itself as 2.56 meter. In diagonal scale, the subunit in the first main division is further subdivided to get the third unit of measure. The principle of diagonal line division is used, which is illustrated below.
Principle of diagonal line division. Referring to figure, let AB be the subunit to further subdivide into 10 equal parts. Erect perpendicular AD and BC and complete the rectangle ABCD. BC and AD may be taken any appropriate length. Now divide AD into 10 equal parts and name the points as 1, 2, 3, etc. parallel to DC and to meet diagonal AC at 1 dash, 2 dash, 3 dash, etc. Scales. Now consider similar triangle ACD and A7-7. We have CD by 7-7 is equal to AD by A7, but A7 is equal to 7 by 10 AD. Thus CD by 7-7 is equal to AD by 7 by 10 into AD, which is equal to 10 by 7. From this 7-10, 7 is equal to 7 CD by 10 is equal to 7 AP by 10 is equal to 0.7 AB. Thus, we see that the line 11 dash, 22 dash, 33 dash, etc. are equal to 0.1 AB, 0.2 AB, 0.23 AB, etc. This is the principle of diagonal line division. Scales. Problem number 5. The distance between two cities is 600 kilometers. This is represented on a map by a line of length 15 centimeters. Construct a diagonal scale to measure up to 1 kilometer. Find the RF and indicate a distance of 346 kilometers on the scale. Solution. Actual distance is 600 kilometers. This is equal to 600 into 1000 into 100 centimeters. Scale length is equal to 15 centimeters. Therefore, RF is equal to 15 by 600 into 1000 into 100, which is equal to 40 lakhs. Draw a line AB 15 centimeters long and divide it into 6 equal parts. Each main division thus representing 100 kilometers. the scales. Erect perpendicular AD and BC and complete the rectangle ABCD. Subdivide the first main division into 10 equal parts, each subdivision representing 10 kilometers. Join 9th division with D by lines 9D. Draw lines parallel to 9D through 8, 7, 6, etc. 0. These are the required diagonal lines. Next, divide the vertical line ED2 into 10 equal parts and name from A towards D as shown in figure. Draw horizontal lines through each of these revision points. Print the units name at appropriate place and indicate the scale. To mark the distance of 346 kilometers, select the point of intersection of 4th diagonal division and 6th horizontal division on first main unit. Name this point as E. Draw a line EF up to 3rd main division. This line indicates 300 plus 40 plus 6. This is equal to 346 kilometers. Now problem number 6. A rectangle plot of land of area 0.45 hectares is represented on the map by similar rectangle of 5 square centimeters. Calculate the RF of the scale. Also draw a diagonal scale to read up to single meter from the map. The scale should be long enough to measure 400 meters. Solution: 1 hectare is equal to 10,000 square meters. Therefore, 0.45 hectare is equal to 45 meter square. On representation, 5 centimeter square is equal to 45 meter square, or 1 centimeter is equal to 900 meter square. 1 centimeter is equal to 30 meter, which is equal to 30 into 100 centimeters. Thus, RF is equal to 1 by 33,000. Therefore, maximum actual length is equal to 400 meters, which is 400 into 100 centimeters. Now scales. Therefore, scale length L is equal to 1 by 3000 into 400 into 100 is equal to 33.33 centimeters. Since this length is in fraction, let us choose 300 meters length, for which scale length L is equal to 1 by 3000 into 300 is equal to 10 centimeters. Draw a line of length 10 centimeters representing 300 meters. Divide this into 3 equal divisions, each representing 100 meter. produce the line by one more division to the right to get maximum length 400 meters. Complete the scale as discussed in previous problem and as illustrating in the figure. Now vernier scale. Vernier scale. This scale consists of primary, that is main scale, and vernier scale. The vernier scale slides along the main scale, which is nothing but a plane scale. The vernier scale is modified form of diagonal scale. This is also used to read 3 units, the third unit being the fraction of the second unit. The smallest division in the main scale is called as main scale division or MSD, and the division on the vernier scale is called as vernier scale division or VSD. Principle of vernier scale construction. First, the main scale is constructed as the plane scale. A length of n plus 1 or n minus 1 divisions on main scale is taken and divided into n equal parts representing the vernier scale. Thus, one division on vernier is 1 VSD is equal to n minus 1 by n or n plus 1 by n. That is, 1 VSD is equal to 1 minus 1 by n or 1 plus 1 by n. Thus, VSD is either smaller or greater than MSD by value equal to 1 by n. The difference between 1 MSD and 1 VSD is called least count or LC. LC is equal to 1 MSD, approximately 1 VSD. The two types of vernier scales are as follows. Forward vernier or direct vernier. In this vernier, the VSD is smaller than MSD, and also the vernier division are numbered in the same direction as the main scale division. If the least count needed is 1 by n MSD, then LS is equal to 1 MSD minus 1 VSD. That is, 1 by n MSD is equal to 1 MSD minus 1 VSD, or 1 VSD is equal to 1 MSD minus 1 by n MSD, which is equal to n minus 1 by n MSD. That is, the angle of n minus 1 main scale division is taken as vernier scale length and divided into n equal parts. Backward vernier or retrograde vernier. In this case, the VSD is greater than MSD and the vernier division are numbered in the opposite direction of the main division. N plus 1 main scale division are taken as the length of vernier scale, and this is divided into n equal parts. LC is equal to 1 VSD minus 1 MSD.
Problem number 7. Construct a vernier scale having a least count of 0.01 centimeters and long enough to measure 5 centimeters. Show the following distance on the scale. A. 3.15 centimeters and B. 2.39 centimeters. Select the scale of 2:1. Solution. RF is equal to drawing length divided by actual length, that is equal to 2 by 1. Maximum distance to be represented is 5 centimeters. Then scale length is equal to RF into maximum length, that is equal to 2 by 1 into 5, that is equal to 10 centimeters. Draw a line 10 centimeters long and divide it into 5 equal parts showing 5 centimeters on scale. Divide each of above parts into 10 equal parts to show millimeters. Thus, now 1 MSD represents 0.1 centimeters or 1 by 10 centimeters or 1 millimeter on scale. Least count LC is equal to 0.01 centimeters or 1 by 100 centimeters, or least count is equal to 1 by 10 into 1 by 10 centimeters, that is equal to 1 by 10 main scale division or MSD. For forward vernier, least count LC is equal to 1 MSD minus 1 VSD, that is 1 by 10 MSD is equal to 1 MSD minus 1 VSD, or 1 VSD is equal to 1 MSD minus 1 by 10 MSD, that is equal to 9 by 10 MSD. 10 VSD is equal to 9 MSD. Take 9 main scale divisions as vernier length and divide it into 10 equal divisions as shown in figure. Now, each of these parts will show a length of 0.09 centimeters or 0.9 millimeters. To show the distance 3.15 centimeters, it is split into two lengths, one on the main scale and one on the vernier. One vernier scale division is equal to 0.09 centimeters into 10, that is equal to 0.95 centimeters. 5 vernier scale division is equal to 0.09 centimeters into 5, that is equal to 0.45 centimeters. Vernier length is equal to 0.45 centimeters. Main scale length is equal to 3.15 minus 0.45, that is equal to 2.7 centimeters. Similarly, for 2.39 centimeters, vernier length is equal to 0.09 centimeters. Main scale length is equal to 2.39 minus 0.09, that is equal to 2.3 centimeters. For backward vernier, least count LC is equal to 1 vernier scale division minus 1 main scale division. That is 1 by 10 MSD is equal to 1 VSD minus 1 MSD. 1 VSD is equal to 1 MSD plus 1 by 10 MSD, that is equal to 11 by 10 MSD. 10 VSD is equal to 11 MSD. Take 11 main scale divisions as vernier length and divide it into 10 equal parts as shown in figure. Now, each of these parts will show a length of 0.11 centimeters or 1.1 millimeter. To show a distance of 3.15 centimeter, 5 vernier scale division is equal to 0.11 into 5, that is equal to 0.55 centimeter. Vernier length is equal to 0.55 centimeter. Main scale length is equal to 3.15 minus 0.55, that is equal to 2.6 centimeter. To show the distance of 2.39 centimeter, vernier length is equal to 0.11 into 9, that is equal to 0.99 centimeter. Main scale length is equal to 2.39 minus 0.99, that is equal to 1.4 centimeter. Thus, 1 by 10th of a centimeter can be measured in main scale and 1 by 100th centimeter can be measured in vernier scale.
Of comparing scales. Now this is the end of the scales chapter. Thank you.